In this session we are going to discuss another problem. This one is the block of weight 15 Newton and it is pressed against the wall by a force of 12 Newton, right? There is a friction between the wall and the block. The static friction is 0.6 and the coefficient of kinetic friction is 0.55. We have to find the magnitude of friction force between the block and the wall, and we have to find the extension of the block, right? And the extension due to gravity will be taken as 10 meter per second square. Now the most important part, what will be the basically approach for this problem? Our approach is that first of all we have to assume that the block is at rest with respect to wall, but it has the tendency of relative motion vertical downward due to the force of weight 15 Newton. Now by taking this assumption, we have to find the value of the friction force. Obviously, the friction force exerted on this block by the wall is static friction, because our assumption is that the block is at rest. If the value of the static friction will be less than limiting static friction force, then our assumption is correct, otherwise it will wrong. First of all, we have to check that our assumption is correct or not. We have assumed that the block is at rest on the wall and the block is not sliding along the wall, right? But the block has the tendency of relative motion vertical downward. Hence the frictional force acting on the block is static friction, which acts upward, right? Because the block has the tendency of relative motion vertical downward, and this friction force must be less than or equal to limiting static friction force Fs if our assumption is true. First of all, we have to draw the free body diagram of the block, right? You have to take the block, and the different forces which are acted by the surrounding are, this one is the applied force 12 Newton, right? Next one is the weight mg, which is 15 Newton. This force is applied by the earth. Next one is the normal reaction acted by the wall, and the last one will be the frictional force acted by the wall on this block. Obviously the friction force will act vertical upward because the block has the tendency of relative motion vertical downward according to our assumption. Now we have to apply the Newton's second law to find the value of F. For this we have to apply the Newton's second law along y axis, and the net force along the y axis will be 15 minus F, that will be equal to mass into acceleration. But the acceleration of the block is 0 according to our assumption, hence 15 minus F will be equal to 0, right? Hence the friction force will be equal to 15 Newton, and this friction force will have the nature of static friction, right? And this, now we have to find the value of limiting static friction force. We can compare the value of static friction 15 Newton with the limiting static friction force. To find the limiting static friction force, we have to write down Fs will be equal to mu s into r, where mu s is the coefficient of static friction. The value of coefficient of static friction in the problem is 0.6, and the normal reaction is 12 Newton, right? How can you find the normal reaction 12 Newton force? You have to apply the Newton's second law along the x-axis, right? The net force along the x-axis is 12 minus r. This 12 minus r will be equal to 0. Obviously the block does not have any extension along the x-axis, hence 12 minus r will be equal to 0. That's why r will come out 12 Newton. After finding the value of normal reaction r and the given value of the mu s, we can find the value of Fs, that will come out 7.2 Newton. Now this 7.2 Newton is the limiting static friction force. That means 7.2 Newton is the maximum value of static friction force that can be exerted by the wall on the block. But according to our assumption, the static friction will come out 15 Newton. Obviously our assumption is wrong, because static friction never be greater than the limiting static friction force, right? Hence the block is in motion vertical downward, right? And the frictional force acting between the block and the wall is not the static friction. The frictional force exerted by the wall on the block is kinetic friction due to the motion of the block vertical downward on the wall. Now we have solved the problem once again by taking the kinetic friction force, right? Now once again we have to draw the free body diagram of this block, right? The forces which are exerted on this block is 12 Newton, that will be the external force. Next one is the gravitational force, that means weight mg exerted by the earth on this block, that is 15 Newton. Next one is the normal reaction r, and the kinetic frictional force Fk which will act vertical upward due to the relative motion of this block on the wall downward, right? Now we have to apply the Newton's second law along the y-axis. Obviously the net force along the y-axis is 15 minus Fk, right? But we do not know the value of Fk. That's why we have to find the value of Fk, right? Now Fk equal to mu k into R. Mu k in the problem is 0.55, but the normal reaction, once again by applying Newton's second law along the x-axis, we can get the value of normal reaction 12 Newton. Now Fk equal to mu k into R. The value of mu k is 0.55 and the value of R is 12. That's why the kinetic friction force will come out 6.6 Newton, right? Now by applying Newton's second law along the y-axis, that is the 15 minus Fk, and Fk is 6.6 Newton. Hence the net force along the y-axis vertical downward is 15 minus 6.6. That will be equal to mass of the block into acceleration of the block along y-axis according to Newton's second law. The mass of the block is 1.5 kg. Why? As the weight of the block is 15 Newton, hence the weight equals to mass of the block into acceleration due to gravity. The value of acceleration due to gravity is 10 meter per second square. From this you can get the value of the mass of the block equals to 1.5 kg. From this equation we will get the value of acceleration along the y-axis, which will come out 8.4 divided by 1.5. After simple calculation, you will get the value of 5.6 meter per second square is the acceleration of the block along y-axis. That means along the vertical downward direction on the wall. Once again, we are going to revise the approach of this problem. First of all, you have to assume that the block is at rest with respect to wall along the vertical direction, and then find the value of static friction. The value of static friction will come out less than the limiting static friction force. Hence, from this working, we can conclude that the block is moving along the vertical downward direction. That's why we have to apply the kinetic friction force. Now, once again draw the free body diagram and apply Newton's second law along the y-axis and along the x-axis. That means along the vertical direction and along the horizontal direction. And then after that you can get the value of acceleration of the block along the y-axis, right?